Okay, this is subsetSum part 2. It's important that you watch the first part video before watching this, but now we're going to talk about how to actually write the code for subsetSum. So we're going to go here and we're going to take the code. First, we'll get rid of this bigger example. We don't need that. And we'll comment out even this. So when we run this, this is what we want to happen. Okay? And so what we're going to do is simply delete the code, and we'll delete this code. And now we have to write this. And sure enough, it fails right away because it says I'm trying to write a subsetSum solver. I gave it a list and a target, and it wasn't expecting that. Cool. So let's immediately get started by saying in our init, we'll take self, the list, and the target, and we'll store the list and the target in self. Okay, and the other thing, just for kicks, we'll do is we will go ahead and assert that the smallest value in L is greater than 0 because we said require all numbers be positive. We could go further and require they be integers, but this is enough for now. Cool. Okay. Now, if you look back up here, we were told we had to set self.startArgs and self.startState in init. So we have to do that. So our startArgs, those are easy enough because that's just L and target. That's just for print report to be able to print those out. But our start state is what? Okay, so now we have to start thinking about the state that we need as we're going along. As you recall from the video, part 1, we said that each move was going to be to use or not use the next value. And then if we're using the 3, for example, the 3 goes into our partial solution, and then the remaining values become everything but the 3. So our state really comes down to two things: the remaining values we need to look at, and the partial solution that we built so far. So we need to go here, and we have an init. Oh, by the way, our state extends the generic state that we have from above, just as our solver extends the generic solver from above. So we said we had remaining values and a partial solution. And we have to store those. And the partial solution is the partial solution. Cool, if you know how to type. So that's fine. Now our start state will be a new state, a subsetSum state. Our starting remaining values are all the values, and our starting partial solution is nothing. Okay, so sure enough, we run, and is solution state. By the way, this is not a bad way to write your code. If you've thought about how you want to structure it, then kind of let the solver drive you through the different parts that you need to write. So is solution state. We need to tell whether or not a state that's one of these things is in fact a solution state. So down here, we'll do def is solution state. It takes a state. And what's it going to do? Well, what we can do is we can take a sum of the state's partial solution. Those are the values that we've included so far in our solution, and simply verify that it's the target. If it is, it's a solution state. And if it's not, it's not. Cool. Get legal moves. Okay. So get legal moves takes a state and tells you the legal moves out of that state. You might think that you could just do this. The legal moves out of a state are use and skip. The problem with that, we'll see later, so I might as well solve it now, is it's actually, these are not the legal moves when you're in a solution state, right? So, I mean, when you've exhausted the values that you can use. So if I have no more remaining values, then I can neither use nor skip them. So in that case, I would return an empty list. Otherwise, I would return use and skip. That's great. So now we have to do, I actually have to go here and states is not defined. How about if it's state singular? Cool. So now I have to do doMove. doMove is going to take one of these moves, use or skip, okay, and it's going to take a state, and we're going to create a new state by doing that move on that state. So def doMove, it takes a state and a move, And what do I have to do? I have to apply that move to the state. So the state, if you recall, has remaining values. Okay, right? So let's pull off the first and the rest. The first is the remaining values of 0, and the rest of my remaining values are remaining values of 1 colon. Yeah, we could do this more efficiently using indexes instead of slicing here, but this is good enough for now. Okay. Then there's two possibilities. So the move could be use. If the move is use, then my new state is subsetSum state. My remaining values are the rest of the values, and the ones that I'm going to use are the old partial solution plus that first value. So because I'm using the value, I added it to the end of my partial solution. So my new partial solution is that, and my remaining values are the rest of my remaining values. Otherwise, at this point, the move is skip. We know that. We don't even have to test for it. And in that case, my new state will look similar, except I'm not going to add the first on because I'm skipping it. So I'll just go and do that. Okay. And then I will go ahead and return my new state, and that should do it. Okay. State satisfies constraints. Okay. So as we're going along and we're checking and we're creating these new states, we verify that they satisfy constraints. State satisfies constraints, and that's going to take a state. Okay. And it's actually going to be pretty similar to is solution state. So I'm going to put it up here. Okay, so we're a solution if in fact the sum of the partial solution equals the target. What about as we're going along? As we're going along, we do not have to equal the target, but we violate the constraints if we exceed the target. So as you're going through this list, 3 plus 6 is 9, plus 5 is 14, plus 2 is 16. At that point, there's no need to continue because 16 is greater than 15. So if this was greater than, we'd violate the constraint. So if it's less than or equal, we satisfy the constraint. Okay, and that's it. Cool. Well, there's one more thing, actually. See this solution state? It printed this out because a state prints out both its remaining values. Well, a state's going to, by default, show you all of its contents, basically, all of its fields. Really, the way we've designed this, the repr of your state should actually simply display the actual solution. So we're going to create a repr here. And what we're going to return is our partial solution. But you have to convert that to a string since this is a repr. So we'll do the stir of our partial solution. When we run that, sure enough, our solution state is 3, 5, 7. And we have written subsetSum. Okay. I hope this helps. You might need to go through the video a few times, and you for sure should try to do exactly what we did in this video and rewrite subsetSum from scratch yourself. Good luck with it.